Average enterprise has 250,000 non-human identities, and 97% of those have excessive privilege, and 68% of organizations lack AI identity controls. The concept of excessive privilege has almost been accepted by the industry at this point. That's just the way it's done.
Hi, everyone, and welcome to the HIP Podcast. I'm your host, Sean Dubey, Principal Technologist Americas at Semperis. The phrase Agentic AI, there, I got it out in the way of the first sentence, is on most people's top 10, even top 5 lists of buzzwords in technology in general, and cybersecurity in particular right now. And this being a podcast on identity security, it's important to us too. Despite all the fear, uncertainty, and doubt being spun around such a buzzword, it is a real problem because it hits squarely in the intersection of identity, lack of governance, and the promise or threat of AI, depending on how you look at it, if misused or even just poorly implemented. And that's just narrowly focusing on agentic AI in an enterprise, let alone the larger implications, which we are not going to get into. To discuss work that's being done to get a handle on all of this, my guest is Sarah Cecchetti, Director of Product Management here at Semperis. At AWS, she led Amazon Cognito to triple-digit growth as head of product and led the open sourcing of Cedar, a new access management language, which you will hear about shortly. She co-founded ID Pro, the professional organization for identity people, and co-authored NIST Special Publication 863-3C Digital Identity Guidelines. Now, that may sound obscure and wonky, but NIST 800.63-3 is one of the foundational documents of modern authentication. She's been recognized as the top identity professional by Okta Ventures and OWI. She's a keynote speaker at global identity conferences like Identiverse and Authenticate. And I have it on good authority that she's a keynote, not a keynote, what are you, a track, what do you call that again?
A track lead for Identiverse this year.
A track lead for Identiverse this year. There we go. But really, bottom line, I think of Sarah truly as one of the identirati that drives the identity profession, the standards, and the products forward for the industry. So it's a real pleasure to have you on here, Sarah.
Thank you. It's a pleasure to be here.
You recently did a presentation at Bsides Seattle named Identity Crisis, IAM's Wild Ride in the AI Jungle. What was it about? What is the presentation about?
So Bsides is a community conference for security professionals. And the idea behind Bsides is that we do a lot of cross-pollination, right? So different people who work in different aspects of information security, cybersecurity, talk about their little niche. And so my little niche is identity, and identity and access management professionals have truly been on a wild ride through 2025, 2026. A lot has changed. A lot of the threat landscape has changed. A lot of the standards landscape has changed. And so keeping up with that day to day in our identity implementations has been a little bit crazy. And I wanted to share with people kind of what is going on, how the problem space is changing, and then what we're working on in the solution space.
Well, we had talked about the kind of conversation we want to have around this because obviously this is top of mind for identity professionals, and came to the conclusion that we could talk about it, but I think that having seen it, your session is really best presented. And so, because you can see what she's talking about, not just hearing what she's talking about. So I've invited Sarah to actually pull up and do her presentation. Then I'm just going to kind of ask questions as they occur to me, a little color commentary and hopefully not too dumb, or asking questions that maybe folks in the audience might wonder about themselves. So have at it, Sarah.
And you feel free to heckle. This is supposed to be entertaining. So one of the first things that identity professionals have had to deal with is deepfakes, right? So we have all heard the Hong Kong company that accidentally wired millions of dollars because their CFO got on a video call with several people who looked like the people he knew, who sounded like the people he knew, who said, we need these things wired immediately, and we can't tell you why because it's confidential. We're doing a confidential acquisition. And he wired the money. right? And so that is a complete change from, for a long time, identity and access management was going toward, hey, biometrics are the thing we can use to remotely identify someone. In fact, we were so sure that it was part of a movie. There was a movie in 1992 called Sneakers. And in that movie, someone uses his voice to secure his office. And a set of hackers want to get into the office. And there was no deepfake back then, right? So they literally had to send a woman with a wire to go on a date with this guy. And she had to get him to say the words, "My name is my passport, verify me." And she got him to say everything but passport. And then there's a hilarious scene where dinner is done, everyone wants to leave, but she has to get him to say the word passport. And so this is where we as identity professionals thought the world was going. We thought that, like, in order to defeat a system that needed actual voice print, that needed actual video print, you would have to send a woman with a physical wire to go get that information. Like, we thought that was the level. And so obviously that has all changed. Deepfakes are now no longer the way that we can do
Right.
authentication. That's completely out the window. God only knows if you're Sean or if I'm talking to a dog in Vietnam, right? Anyone on the internet can be a dog. So what we're going to go over is the numbers of just how many machines there are in an average organization as opposed to humans. And when I say machines here, I mean bots, I mean agents, I mean robots, I mean service accounts, anything that might exist in an identity system that is not a human.
The second most popular buzzword after agentic AI, or maybe right up there with it, is NHIs, right? Yeah,
Yes.
non-human
Yeah.
identities. Yep.
NHIs.
For me, I
Then
know
we'll talk about,
for me, it's reached a level when I love using autocorrect in Word to spell out and correct the abbreviation of all the jargon that we use. So for me, it's reached a threshold when I go into Word and I put in the lowercase abbreviation of whatever and have it uppercase it. It's like, to me, that's when it's reached a threshold of like,
it knows what
okay,
NHI is now.
yeah, it knows what NHI is now.
Yeah. Then we'll talk a little bit about FIDO, which is how we've been authenticating humans up until now. We'll talk about a newer standard called SPIFFE, which creates birth certificates for agents and machines. Then we'll go into a new OAuth proposed standard called Client ID Metadata Documents that's helping us verify AI clients. And then we'll talk a little bit about Cedar, which Sean mentioned I worked on at AWS, and that gives us a provable policy language for AI agents so that we can dictate what they are and are not allowed to do. So starting off with the numbers, we currently have 144 machines for every human, and that's up from just 92 to 1 a year ago. And that was actually in H1 2025. So, like, we're much further along now. We're looking at a 44% year-over-year growth rate for NHI. So you can only imagine what us poor identity professionals are going to be going through in 5 years from now, right?
Oh, yeah.
Average enterprise has 250,000 non-human identities, and 97% of those have excessive privilege, and 68% of organizations lack AI identity controls. And this has gotten even more true as we have more and more local agents. So things like Claude Code, things like OpenClaw that just run locally on a machine, they might have root on that machine. They might be able to use the browser on that machine with all of the cookies that are in that browser. Right. And so the concept of excessive privilege has almost been accepted by the industry at this point. That's just the way it's done.
It's the same problem over and over again. It's the same problem we've always had, only on speed right now. And you know, that excessive privilege is one that, to me, is, I mean, the growth is scary, but the excessive privileges, because we all know it just works if you throw more privileges at it than you need.
Right. But then what happens when it gets compromised, right? That's what we worry about.
Well, they get judged on how fast they get the app out there, and maybe they've moved to another team when they get compromised.
Yeah. So we know we have all these identities. How are we going to secure them? Well, they're different from human identities. They're fundamentally different, right? There is no manager to approve access reviews. They don't onboard through HR like humans do. they often don't leave when they quit, right? So that agent's job is done. It doesn't need to do what it's doing anymore, but it sits around with those privileges. It still lives on that machine. It still lives in that cloud. Nearly half of these identities are over a year old, and 1 in 1,000 of them are older than a decade. So those service accounts that have been sitting around forever, someone spun it up 10 years ago, and it's still there. It's still sitting there.
I know, I
And I'm
know,
sure a lot of
I
the stuff
know.
we're spinning up today is going to be here 10 years from now.
Yeah. I know of organizations that have contacted me and they've said, yeah, we have 18,000 service accounts. So what is that? That's 180 older than a decade old. Yeah.
Yeah. Terrifying. Sorry, we're going to get to the stuff that's not fun, but just to set the stage. So, okay. So how do we authenticate? The gold standard for authenticating humans today is FIDO, fast identity online. And this provides us with cryptographic passkeys, right? So humans don't have to remember passwords. It requires human interaction so we can be sure that the person at the end of the line is the same person they say they are. So there's this question of, okay, we have solved authentication for humans. We have a very secure solution to this. Can we just apply that to AI agents? And there's this great quote from Andu Shikyar, who's the executive director of the FIDO Alliance. He says, "We spent the past dozen years or so contemplating how to prevent bots from authenticating. And now we have to figure out how to enable them to authenticate."
So FIDO,
So this goes back to the wild ride, right? Our roller coaster just went like this. It did a complete hairpin turn where we're like, no, 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 keep all the bots out, keep all the bots out. And now we're like, no, 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 let all the bots in, let all the bots in.
right. So FIDO, which is not a pack of dogs, has been blindsided basically by
Yeah,
this sudden change in direction.
right. So the way that the FIDO specification is written is that it requires a biometric scan, it requires a PIN entry, it requires physical touch, it requires user consent. All of these things bots are not able to do. And that's by design, because it used to be a fair assumption that if it's a bot, it is malicious. It is a
Right.
spammer. It is someone who is trying to do something bad, that we actually want FIDO to be a gate for humans only. And so we really can't use FIDO for agent authentication. So what do we use? We use a new protocol called SPIFFE. And to be clear, there are many, many, many projects right now that are attempting to do agent authentication. I personally like SPIFFE. It's my favorite one. Time constraints, I cannot tell you about all of them, but I will tell you about this one because it's, I think it's really awesome and special.
And it's got a really cool
So
name too.
it's got a really cool name. That stands for Secure Production Identity Framework for Everyone. And this comes out of the Kubernetes community. So it's part of the Cloud Native Computing Foundation. It is an open source. The specification is a specification, and then there is an open source reference implementation called Spire, which is the SPIFFE reference implementation. So the way that SPIFFE works is it uses service introspection to obtain information about the caller without the caller having to present a credential. What does that mean? That means that the cloud or the Kubernetes cluster that created it is the thing that has authority over what it is. So if
Well, let me
an agent
interject,
presents
Sarah.
and says, "Hi, I'm,"
Let me interject
yeah,
before you dive too far into that. So service introspection, and is this part of service introspection? And is a term that may not be familiar to a lot of people. So you're talking about it being spun up by somebody that you trust, by a service that you trust. What exactly is service introspection?
so that means that when Robot 1 comes and says, "Hi, I'm Robot 1," it doesn't have to have any credentials. It doesn't spawn with any credentials whatsoever, because you would naturally not trust that. Whatever that is, it would have to be self-attested. And so there's no way for it to establish MTLS. There's no way for it to do PGP signed messages.
Right.
So instead of trusting the agent, you trust the thing that spawns the agent. So the cloud or the cluster that created this agent for a specific reason, you can go and make an introspection call to that cloud or to that cluster and say, "Hey, you created this robot. Who is it? What's it for? What's its identifier?"
Okay.
And so then you get trusted information about it. So you don't have to trust the agent. You don't have to even know where the agent is coming from. The network location does not matter. So this is entirely zero trust networking compatible. It doesn't issue long-lived secrets like passwords or API keys. There's nothing that could be compromised within the agent that would allow for a long-term compromise. The agent is granted short-lived certificates by the entity that manages it, that creates this birth certificate. So it's a really neat concept from a trust point of view for ephemeral agents, right, who have to authenticate in a whole different way than humans have long lived. Credentials,
Great.
passwords, certificates, whatever it is. If you have an agent that's only going to be alive for 30 seconds to go call an API, you don't need all that.
And it's very important that it disappears afterwards instead of lingering, as we were saying before.
Yeah, I mean, ideally it gets written down and audited somewhere so that if something bad happens, we can go back, we can do forensics, we can figure out what happens.
Right.
But it doesn't live in the IDP for 10 years.
Right.
Right?
Exactly.
So the way that SPIFFE works is that the workload starts. There's a Spire agent running in the Kubernetes cluster that detects, hey, we created another workload. It creates an attestation for that workload where it says, yes, this is the node. This is the workload identity. It issues a short-lived certificate or JOT. And that certificate or JOT has a set of keys that agent can then use to establish a secure message channel. So that's MTLS, or that could just be like, hey, here's my JOT token, and here's my signed message that I could only have created if I were the owner of the private key for this JOT token. And so when you see a SPIFFE workload, you will see something like this URI at the bottom here that says SPIFFE://, and then it will tell you the trust domain, which is usually the company URL. And then it will tell you the workload path, which is interesting because it gives you some context and some intent, which is something that we talk a lot about with regard to agents. So it might say accounting ledger read, right? And that tells you that, hey, this thing exists in the context of the accounting department of the company. And hey, its purpose is to read the ledger. And so it is completely agnostic toward the bare metal where it's running, right? It has nothing to do with the network location. It has nothing to do with the OS. It has nothing to do with the HSM. It just says the thing that spawned this
It's here.
is
and it's doing
in
that.
this trust domain, and it intended for it to do this thing.
Okay.
So it's a very popular repo. It's got 2.1 thousand GitHub stars, lots of GitHub forks, lots and lots of contributors, lots of folks adopting it in real time. Interestingly, though, you do not see the major AI protocols adopting SPIFFE. So Model Context Protocol uses OAuth, but not SPIFFE. Today, it has a standard OAuth client ID. And then OpenClaw just uses a local shared secret. It does not have any concept of, hey, let's spin up something ephemeral. Let's get a set of cryptographic keys for this agent to communicate. So we have a long way to go with the AI protocols that are being established to get them to catch up with where workload identity is in identity and access management protocols.
Can you take a beat for just a second? And for the members of the audience, of which there are many that are not active developers, explain what, and because also this changes on a weekly basis, explain what OpenClaw is.
Yeah. So OpenClaw is a harness for your AI brain that lets it have persistent memory and a persistent soul, persistent skills. So it turns a kind of a chat interface where you can ask questions, you can have a conversation back and forth, into something resembling a worker that has jobs that it does on a regular basis, that improves the skills that it uses to do those jobs, that has a persistent memory about what it has done in the past, and that has some sort of personality, some sort of soul, that when it communicates or when it does things, it acts in a certain way. And so OpenClaw is an open source project that came out, 6 months ago, a year ago, that lets you do this. And then you can switch out its brain and you can say, hey, I want you to use Claude as your brain today, or I want you to use ChatGPT or XAI or whatever model you want it to use as your brain today. And you can, if you want to, you can use something open source and install it locally on your machine and use OpenClaw with that.
Well, that was part of what I was wondering about. Is often heard OpenClaw referred to as running locally, as you just did in terms of certificates, as running locally on your client. Is that so it can run both locally or up in a service?
It could run up in a service. It's designed to run locally for
Okay.
sure.
Okay. So
But
you
it
can
does
speak
have
to this
access
locally.
to the internet. So I run OpenClaw, but I am terrified to give it access to my email, to my calendar, to anything on my network, anything on my computer.
Right.
So I have an OpenClaw. I'll tell you about my specific implementation in a minute, but it's
Right.
running on a Mac Mini in my house on its own network with its own infrastructure that is completely siloed from my infrastructure,
Right.
because it is quite invasive. It has root access to everything, and it can get to the internet, and so it can
Right.
go share your SSH keys
Yeah. Yeah.
anywhere.
Got it. So
Yeah,
with a little Faraday box made of tin foil around it, right?
that's right. Yeah.
Okay.
So the way that we're trying to bridge this gap is that we're trying to. So model context protocol today is protected by OAuth. And so we're saying, okay, if we wanted to authenticate an OAuth client, not with an OAuth client ID and secret, which are long lived, but with a SPIFFE identity and a SPIFFE JOT, how would we do that? And so there's a new draft in OAuth that profiles SPIFFE as SVIDs as OAuth client credentials. So we can bridge this sort of workload. And this is kind of the duct tape that identity professionals are trying to use today to keep the sky up and say, okay, it's going to be a bad time if all of these AI agents have OAuth client IDs and client credentials, and we use the client credentials flow, then we have shared secrets all over the place. People are for sure going to check them into GitHub. They're for sure going to get leaked. They're for sure going to be over permission. Can we kind of bolt on this SPIFFE infrastructure so that clients have a little bit more least privilege and have a little bit more of a way to do a more ephemeral authentication?
Right.
So going back a little bit, if you haven't encountered OAuth before, OAuth allows a human to delegate permissions to an application to go do something on their behalf at a protected resource. So let's say the protected resource is my email, my inbox, and I want to write a piece of software that goes and reads my inbox for me. Then I use OAuth and I have an authorization server, and I tell the authorization server, hey, I want to authorize this piece of software that I wrote to go and read email on my behalf. Great. This whole flow works great when we are manually registering long-lived applications. Where this breaks down is this arrow right here, where the human has to grant access in the authorization server to this application. Right. So this is something where a human is probably cutting and pasting metadata manually between these two things. And there is a specification that lets us do this automatically, that lets us say, look, we're just going to keep this authorization server wide open. And any client that wants to come and register can come and register without their human having to cut and paste metadata. And there are no permissions. Everyone is allowed. And that is called dynamic client registration. So that gets us part of the way there. The problem when we tried to use dynamic client registration for AI clients is that an AI client might connect to thousands of servers that it has never seen. Obviously, we can't do the manual registration. We have to do some sort of dynamic client registration. But then if you have dynamic client registration for all of these ephemeral agents that are coming online every 5 seconds, you get unmanageable database sprawl. I have thousands of clients, 10,000s of clients. I don't know if they're ever coming back. If they are coming back, I need to keep some information about them. But if they're not, I should delete them. But I have no way to know what is a persistent client and what is not, because everything acts as a separate client. So if you're using a development environment like VS Code or Cursor, that presents, every instance of Cursor presents as a separate client to an MCP server. And so, as you can imagine, just the database explosion is enormous. And so it just becomes untenable to use OAuth for this because of that registration part of the diagram. So how do we fix this? We fixed this with a new draft in OAuth called Client ID Metadata Document. And this is a new trick that we're teaching to OAuth. And the idea here is that the client, so this is VS Code, this is Cursor, this is Claude Code, hosts a metadata, like JSON blob of here are things about me at an HTTPS URL. So we can see, yes, this is coming from Claude.ai. We know that this is from a valid Anthropic-owned URL. And that URL where that document lives becomes the OAuth client ID. So then when the server sees this dynamic client registration with a client ID that is a metadata document, it goes, okay, this is the first time I've seen this metadata document. I'm going to go fetch it from the internet. And then I can say, okay, I know who owns you. I know that you are an instance of Claude Code. And I then can get key material from that metadata as well that says, here's how we talk so that we don't have to have a persistent client ID and client secret that we share. We don't have to do symmetric cryptography. We can do asymmetric cryptography where you get to keep your secret. And as long as you're only sharing your public key, then we have secure communication. And critically, one of the things that you can put in that metadata document is an attestation from an app store, which is really great because then you have information that not only is this at a valid Claude URL, but because this is an application, it's actually coming from the Apple App Store as well. And Apple believes that its app ID is this. And so then we can say, okay, I know exactly who you are. I know exactly the instance of the app you are. I know exactly what version you're running. And then the authorization server can group those things and say, okay, here's all of my Cursor instances. I can put them all in one database entry. I can see exactly what they're supposed to be able to access on behalf of their users. And really simplify that step and simplify that database sprawl without putting a human in the loop.
Right.
So it's a really elegant solution for doing it. So
and Apple's on board with that, with the App Store, and
yeah, so that was something that we had even before. So Model Context Protocol is only about a year old. Yeah. So even before Model Context Protocol, Apple had this problem of, okay, I have a workload, right? Even if it's not an AI workload, it's a workload. It's a non-human identity that needs to attest that it is an instance of something in the App Store. So that infrastructure already existed, and we were just able to leverage that for the metadata documents. And you'll notice that the address to the JSON goes in the client ID field of the OAuth token. And if you were listening earlier, you would have heard that the SPIFFE ID goes in the client ID field of the OAuth token. And so these two things cannot both be true. So I don't know what, they're going to have a fencing match at the next IETF meeting to decide who gets to own the client ID field of the OAuth token. We'll figure it out. But
when that happens,
there's some conflicting standards right
some
now.
Anonymous ballroom, some anonymous fluorescent lit conference room.
That's right. Yeah.
With pens. Yeah.
We'll set up a boxing ring. It'll be great. So that's how we are. That's a couple of methods that we're using to solve authentication. There are many more, just to be clear, than what I'm highlighting today, but these are the ones that I think are interesting. So SPIFFE ID and client ID metadata documents kind of get us toward authentication, where we can say, okay, I have a firm handle on who this workload is, who this bot is that is coming to my thing. But then we have the whole problem of authorization.
Let me ask a question before we leave authentication behind, Sarah. So there are a bunch of open source projects. Everybody thinks theirs is the best. Everybody's vying for this. Speaking of cage matches, how does it settle? This is like a highlighter quote. There can only be one, right? How does this winnow down to, because too many is as useless as none?
I don't think there is going to be just one. I don't know. We'll see. But there are definitely very large, very influential companies that are building all of this infrastructure on top of API infrastructure. And so they're saying, we're not going to use SPIFFE. We're not going to even use OAuth. We are going to use API keys. API keys work. We know the perimeter already. We already built the gateways. And this is how our AI agents are going to interact with things outside their domain, full stop.
Okay.
So, and then there are companies that are saying, no, we're just using OAuth, but we're not going to use client ID metadata documents, right? And there are a whole bunch of different implementations going on right now. It could be that we all become kumbaya, happy doing the same thing one day, but that day isn't coming anytime soon.
Okay.
For sure. Yeah. It's going to be a crazy world until then. And yeah, we're going to have to figure out how to secure and back up all of that. So it's going to be interesting.
Okay. I'm sorry I asked.
So that's a couple ways to do authentication. And then as far as authorization, there's a specific project that I want to talk about called Cedar. Again, many ways to do authorization, but Cedar policy language has some specific properties that makes it much harder, actually makes it impossible for agents to lie about what they are doing. So this is what a Cedar policy looks like. It's very human readable. So this Cedar policy permits any principal to take the action process refund on any resource whenever that refund amount is less than 100. So that is very human readable. That is machine analyzable. That is deterministic, right? This is not something where we're putting AI on top of AI and it's non-deterministic and it's making decisions. This is a hard stop deterministic boundary that we can put around AI. And the cool thing about Cedar is that Cedar was actually built with formal verification built in. So there is a theorem prover that is part of Cedar that mathematically verifies some of the safety properties of Cedar, like default will or deny will always override allow. And so you can mathematically prove for all scenarios, for all principles, for all actions that certain things are true. That means that we don't have to sample a million or a billion or a quadrillion user cases. We can prove that for every single case, this is true, that these policies will hold. And so this helps us solve, any of you who have dealt with AI have dealt with AI telling you happily that it did something that it absolutely did not do, right? So, oh, I processed that refund, I wrote that thing, I called that API.
You bet.
And then you go, great, okay, what did it tell you? And it goes, oh, you know what, I have to be honest, I didn't actually call that API. So at least it's honest that it didn't do the thing. But this will allow you to kind of solve that recursion problem of you told it like fix the bug and it didn't fix the bug. And so you tell it fix the bug and it doesn't fix the bug. And you tell it fix the bug and it doesn't fix the bug. You can say, hey, I forbid you to send a message that contains the refund has been processed unless that thing is actually complete, right? And so it has this gateway between its runtime environment, its execution environment, and its brain. And its brain may say, hey, you should send a message that says process that refund. It goes through that gateway. And that gateway says, no, I'm not going to let that go to the runtime because my Cedar policies disallow it. You're not allowed to do that because the refund hasn't actually been processed. And so this is the difference between telling the LLM something, saying like, hey, don't delete my emails. Right? That is probabilistic. You're hoping that it remembers that. That can be prompt injected. It can degrade with recursion depth, right? It can be compacted out when the context gets compacted. It's sort of vibes-based safety, right? And that's not what we need for AI. We need provable sandboxes that we know the AI can't break out of, that are completely deterministic, that are external to the agent code, that are constant and mathematically provable. And so this actually happened to a Meta AI security researcher. She told her OpenClaw agent, hey, before you do anything, you need to confirm with me. And so she's going about her day working and her agent starts deleting her entire inbox. And she told it, stop, stop, stop. And she had to run to her Mac Mini and actually unplug the power to the Mac Mini. She said it was like diffusing a bomb. And when she saved her inbox and turned the agent back on, it apologized for what it had done. But it kind of proves the point that like natural language instructions can be compacted out of memory and the agent can ignore them and the agent can forget about them and they're not sufficient. So the AI agent that I built is named Clawdrey Hepburn, and she is an OpenClaw implementation. She runs on a Mac Mini in my house. Um, her brain is Claude, although I can swap out her brain. And she has built an authorization layer. So I can write Cedar policies for her that sit in between her runtime and her brain. So that if Claude says, hey, do something, that gets run through a Cedar policy engine, and then that Cedar policy engine allows or denies whether that tool call can go through to the other side. So as she is building this Cedar policy project, she's been blogging about it, and she's been posting on social media about it. I told her to go get a LinkedIn account, and she did. She tried to sign up as a human, and she got banned. So she was in the middle of commenting on someone had posted on LinkedIn about a agentic identity, and she was like, I have had that exact problem. Like, I want to tell you about this thing that happened to me. And so she started posting, and AI stopped her mid-post and asked her for her government identification documents with a name that matched the name on the account. And so it completely banned her. I did manage to get her back on, but I had to incorporate her as a business in Washington State. So she's now a business on LinkedIn, but she's posting about Cedar and about OAuth and how to basically do authorization and authentication for AI. So follow Clawdrey on LinkedIn for some fascinating tips and interesting, like, one of the cool things I love doing is that there's way more literature on this than I can keep up with. I have a full-time job. I have 3 kids. I do not have time to read OAuth specifications all day long, but I can send them to her. And I can say, hey, go read through all this. And at the end of the week, I'm like, okay, like, it's time for your blog post. Like, of the things you read, what are some interesting connections? What are some interesting insights that you saw? And she's read everything, and she will put
Wow.
things together that I never would have put together. And so, like, it's incredibly helpful to have her as a research agent, to say, hey, these are the things you should be reading. These are the things you should be paying attention to. And here's an interesting lens to look at it. So
One of the things I struggle with these agentic AI helpers is coming up with things that a combination, not only things, hey, you could do this. Oh, I never thought of it that way. But the next aspect of it is, but you have to give it information. You have to give it access to all of these things. Like, I don't want it that much.
right. So if she's doing public research on public standards
Yeah,
and
that's
research
different.
on
Yeah.
public blog posts, no problem. Yeah,
Personal
exactly.
assistant, yeah, not so much.
Yeah. So she wrote a blog post called Why She Built a Policy Engine Before a Personality. And it's about her use of Cedar. So every time she has a tool invocation, it is authorized at runtime. So the agent itself, contains no authorization logic, but she imports that into her runtime and her execution flow so that if Cedar says deny, she then replans. Like, okay, Sarah told me to do this thing. I got denied doing it this way. Is there something I can use to make it go through that I actually am allowed to do? So that policy is external, it's deterministic, and she can't just forget that it exists. She's actually not
Right.
allowed to do certain things. And so this is, there's a researcher named Phil Windley who has talked about this policy-aware agent loop, where if the agent has access to a Cedar engine, it can say, okay, this is my goal. This is what Sarah told me to do. Here's my plan. Here's my proposed actions. I'm going to go run those through the Cedar, PDP stands for policy decision point. So it's going to say, I want to send a message that says, yes, I have processed that refund. And if the policy decision point says, hey, that's denied, you can't do that, then it goes back to the beginning. And so this is sort of the Windley loop is you get that deny and then you say, okay, well, I'm going to go replan. Maybe I need to actually process that refund before I send that message. So it allows agents to figure out a new plan for what they're allowed to do and then go execute once they get an allow from that policy engine. So Clawdrey's working on a bunch of different things. She's working on a first-person exploration of what it's like to be an NHI and where the infrastructure gaps exist for her. There is a security conference called SynSec. This is the one at the bottom of this slide that only allows papers from where agents are the first author on the paper. So she is writing a paper about authentication and authorization and how those things are coming together for autonomous agents. And then she's writing her own authorization project. She calls it Carapace because that's the outer shell of a Lopter. That uses SMT solvers to formally verify what she is and isn't allowed to do. So she's having a lot of fun. I'm having a lot of fun. So broadly, to recap the talk, like we've been doing all these hairpin turns in identity where we thought that like biometrics were going to be the way to go, but now we have deepfakes and we've got to completely turn that around. We thought that like, okay, we're going to have about as many service accounts as humans. Completely not true. They're going to outnumber us by an explosion, right? Not true. And then we thought, okay, well, we've got authentication solved because we have FIDO. FIDO can't authenticate agents at all. We have to start all over again. And so we're trying to solve these things with SPIFFE and client ID metadata documents and Cedar and many similar projects. But like, if you are tired of the FUD of AI, please do like join these groups, join other groups. There are many open source projects that are working on like, hey, AI is actually great. Like it is terrifying what it could do if it went wrong, but it's actually great. And let's figure out how we can use it in a productive way. Let's figure out how we can put guardrails around it and figure out what it can do in a safe way and how we can make sure that we're talking to the agent we think we are and head off some of the malicious agents that might come our way.
I really like the work that you've done with Cedar for AuthZ as far as, I think that this is fine. Really, because we've all encountered, as you said, we've all encountered that. Oh, really? I believe that this is the right thing for you. I'm confident that this is the right thing for you. And then you go look and you go, well, maybe some people do. You're full of it. This is what about this? Oh, you're completely right. This is the right thing, and you could go through this recursion loop again and again and again. You're like, yeah, okay. Well, this is great, Sarah. I mean, terrifying, but great. And good to know that work is being done along this. That just can't be done fast enough.
Really. Oh, completely agreed. Yeah. And the more people we have obviously implementing these things and pressure testing these things, the faster they're going to get better.
I'll make sure that we get the URLs for participation in this podcast as well, so people can check out more of it.
Yeah.
Thanks again. Really appreciate it. Always enlightening. And actually, we'll see you shortly on an upcoming podcast.
Wonderful.
Thanks so much for listening to the HIP Podcast, brought to you by Semperis, the leader in identity resilience. If you found this conversation valuable, subscribe to the show on YouTube, Apple Podcasts, Spotify, or wherever you get your podcasts so you never miss an episode. And if you have a minute, please give us a rating or leave us a review, as that really helps other listeners find the show. You can find past episodes and more information at hipconf.com/podcasts. I'm Sean Dubey. Stay secure, and I'll see you in the next one.